Now we're going to solve problem number 9 from your textbook on page 306. Hopefully you've given it a good read already, and maybe even you've given it a try. Now you come to see if we both get this, we all get the same answer. Okay, I've written down the cash flows there for number 9. Have a quick read. A project that provides annual cash flows of $15,400 for 9 years. So that $15,400 for 9 years. Cost $67,000 today. I show that as our cash flow in year 0. Is this a good project if the required rate of return is 8%? Okay, so we know the $67,000 discounted is still $67,000 because it happens in year 0. Now we want to discount all those cash flows of $15,400. Well, hopefully you recognize this as an annuity. So this would be a simple thing to do. Sorry about that. So this would be a simple thing to do. Let's put it in our financial calculator. $15,400 as our payment. Make sure we have the future value zeroed out. We want 8% interest, and we want 9 periods. We're going to compute the present value of that. And I get $96,202. And so we see that the total of those two, the initial investment is $67,000, and the present value of $96,202. Add the two together, we get $29,202. And so this investment is a go, right? Net present value is greater than 0. But what if we need 20%? Okay, so we're going to do this again. Discounted at 8%. Now we're going to discount at 20%. Let's see what we get. We still have $67,000 as the initial investment. But now we're going to put 20% in as our interest rate. See that? 20% is interest rate. And we're going to compute the present value. And we get $62,076. Call it $6,072. And we subtract from the $67,000 initial investment. And we see that we have a $4,923 shortfall from having a 0. And so, in this case, at 20%, we would reject this investment. So now, the next part of the problem asks, at what discount rate would you be indifferent between accepting the project and rejecting it? Well, that will be the internal rate of return. Okay, that will give us a net present value of 0. So there's a couple of things we could do. The simplest, let me do the simplest because I like simple. The simplest is to put in the $15,400 of payments and the $67,000 negative present value. Get rid of the future value. This is 9 years. And we'll compute the interest rate. And we see it's 17.67%. And this we would be indifferent because that's the internal rate of return. Now, this only works when we have an annuity and constant cash flows. If we don't have constant cash flows, we'd have to use the internal rate of return function on your calculator. So let's try that. So in this case, we're going to hit the cash flows button. So that cash flows button. And we're going to put in the $67,000 negative as our cash flow at time 0. And then our cash flow at time 1 is going to be this $15,400. We enter that. We want that 9 times. We'll enter that. I'm going to make sure the rest of these things are just zeroed out. Oops. 0, enter. Here we'll enter so the initial cash flow is $67,000 out, then we have $15,400 9 times, and then we have nothing, and we have nothing, and we have nothing, and we have nothing. Okay, so now we'll compute the internal rate of return, and see that 17.67%. Oh, you've seen that before. Okay, so we can either way, because we had even cash flows, we can just say we want the interest rate that makes the annuity we're going to get in the future equal in value to the initial investment. If we didn't have equal cash flows, we couldn't use the annuity function. So we'd use the cash flows function, putting all the cash flows, both the initial investment as a negative and then the future cash flows, in this case, 9 of them, all the same, all positive. And of course, we'll get the same answer. And that's number 9. Good luck on your homework.